And with that, I would like to introduce Hugh Price, who is the Vice President of Application Delivery and Product Owner at CA Agile Requirements Designer at CA Technologies. Welcome, Hugh.
Hello, can you hear me okay?
I can hear you great.
Good.
I'm going to go ahead and just turn it right over to you and let you do your thing.
Thanks so much. Okay, any problems with audio, just shout and hopefully someone will come and get me. So this is, let's just quickly run on to an agenda, which I knocked up with lots of preparation about 10 minutes ago. What I'm going to do is I'm going to try and keep the slides to a minimum, so I know people get a bit bored with slides, so I'm going to go through them rather rapidly. Obviously there is a recording and we will send you the slides so you can go through these later on. And then I'm going to try and get into live demo and just use the product itself and run various automation scripts, which is always fun, and I'm sure will go perfectly. Okay, so I'm going to actually start with just one customer called Rabobank, based in Utrecht in Holland. And I'm going to actually use their slides. I'm just going to quickly go through their journey and how they went from a pretty good automation framework, keyword-driven, to what we call fully reactive automation, which is you make a change and you can, the automation kind of keeps up. So I'll go through those first of all. I'm going to talk a little bit about test design and coverage techniques, different types of coverage techniques that are out there. If I have a chance, I'll show you, you've designed some test cases, a requirements change, and then you've got to actually then update the existing test cases and how that actually looks. I'm going to do some demos of different types of automations. With luck, I'll show you Selenium, Eggplant, and from a company called Testplant, and then a RunnerX as well. And then I'm going to show you what happens if you get a failure. We've got some quite interesting tools that help you kind of create some more automation scripts to try and diagnose where the failure actually is. And then if I have time, I will quickly show you how you link the test data and possibly the virtual services to the automation. So that's the agenda, so let's crack on. For those of you who don't know, I'm the product manager, product owner for a product called CA Agile Requirements Designer. You could sort of think it as sort of Visio on steroids, really. It's pretty much a flow charting tool. But the idea is that as you design your model of a process, it can then synchronize out to other tools, JIRA, Agile Central, and it can also generate you test cases to cover, to cover decision gates and so forth. You could import your existing test cases. I don't have time to show that today, but you could import them, deduplicate them, clean them up, and generally what you do is you probably reduce them by about a third, as test cases tend to grow. We can design and provision test data and also service virtual endpoints, usually XML or JSON endpoints. And then the thing we're pretty much going to focus on today is this idea of creating automation scripts, and we'll actually go and generate a few scripts for you and try and run them. Okay, but the point about it is that the one tool can do many things, so whether you're just using it to design test cases, whether you're just using it to generate automation or test data, you then get the benefit of being able to do all the other good stuff as well. So faster, better, cheaper, that's the new world order. It used to be the other way around, I think, before. Anyway, so let me just talk a little bit about Rabobank. So Rabobank, the way that they work is that they are they've sort of moved into Confluence and JIRA are their main, so I guess, sources of record and sort of activity tracking. So you have your BAs works with users to understand the desired functionality, and they would, they'd spend a bit of time sort of writing, sketching, drawing, snapshotting and all those kind of things. Then the next thing that happens is that the CA Agile Requirements Designer gets involved, and that allows them to kind of clarify their thinking. It allows them to create models of what the system is supposed to do. Those assets that they work backwards and forwards, and it's almost like a cooperation or collaboration tool, would then end up back in Confluence. So we would actually create images or test cases or user stories and put them back in. Next things that happens is that the Confluence ID would then be passed into JIRA, and obviously we keep track of both, so we kind of know a user story has been created in JIRA. Then we would then generate test cases associated with the user stories, and we would then attach them into JIRA, so that then we've got a link between Confluence to JIRA to user stories to test cases. That's the JIRA Confluence link, and now the test scripts start coming out, and these are in fact automation scripts. Originally they were Cucumber or Gherkin, and keyword driven, and then we actually switched to keyword driven and AngularJS at Rambo. They pushed those into Git, and once they're available in Git and you do your check-in of your code, then you've got your check-in of your test scripts, and then you can move into sort of really advanced release automation and so forth. Then they get the run results, system under test run results comes back in. There's a bit of a missing arrow here that it actually goes back up into JIRA as well and say this test case has failed. The reason that we want them back is that we could maybe do some diagnosis of specifically where in your model things have changed. Okay, so, sorry, things have failed, and then do some sort of more detailed diagnosis. Okay, so first things first, let's just talk a little bit about model-based testing. Now, model-based testing, you could say test-driven development, you could say behavior-driven development, etc. But in effect, they are variations on modeling techniques. Now, what I've got here is some modeling where I've got this is a fairly typical way to approach model-based testing. First thing you do is throw in valid data at a screen. If it didn't find the invalid data, that's a failure. If it found it, then that's a success. And actually, this is, you could call this sort of negative testing, but actually you should probably be doing a lot more negative testing than you are currently at the moment. We usually find it's about 5%. It should probably be about 80%. Then you've got the idea of valid data passing through. If the valid data gets rejected, that's a bug. If the process doesn't do what's expected, that's a bug, and so forth, and it passes it on. So being able to break your tests down into that, and this actually mirrors quite well into the way that you generate your automation. You should sort of almost think, I am throwing in valid data, that's my expected results. If I get that, then that's a failure. So invalid turns to valid, which is failed, and so forth. So you get these kind of double negatives going on. Now, the reality is that it's very rare that you actually think of a single process. You could think of this as maybe an API, or it could be even, you could think of almost like a UI as the same kind of process, and you're kind of working your way down through processes, and you've got the same kind of model approach as you move through chained processes or UIs or service calls and so forth. So it's a similar type of approach, similar sort of structure to it. So if you look at something like a UI, so you've got a customer number, there is a certain degree of validation that we've got on that customer number. You could throw blanks at it, nulls at it. You could throw maybe a security penetration test at it. You then get information that's pulled back out into the screen, and then you're back into a process type thing where you change the customer name, and that's again empty, and you need to worry about that, and so forth. So it's a validation of process, it's a validation and so forth, and you're working your way through. Now, you could also roll in other types of testing into this. In this case, I could actually force in a failure for maybe like a SOAP call. Now that's actually kind of a negative test which needs to be correctly handled. So you could do something like that. You could maybe do something like add in a performance testing test in there as well. But the idea is you need to be quite systematic about the different types of tests that you're doing. And then when you generate your automation scripts, you kind of know where you are in terms of what the actual expected results are. Okay? So the way that the tool works is that we are very much into the idea of generating automation scripts. We had one customer who had 30 automation specialists, and they were running at about 3 months behind because it took them so long to maintain those scripts. And what they would do, and what they've now moved to, is generating all the scripts, and the scripts then come out virtually at the same time as you're making the change to the requirement. It's the same, and the 30 people actually went down to 6 people on that project. It doesn't matter whether you're using Keyword or Cucumber or something like that. You still have the main problem is if you actually change the application, you've got a bunch of existing assets that you've got to go back through and actually change the existing test cases. Do they still make sense? Do I need to change them? And that can be very boring and very time consuming, and there's a lot more to be done in life than plowing through existing automation scripts. So we have automation text blocks, automation objects, we have the concept of model-based tests and test data, and out of that we would then create the scripts that we're going to talk about. So Selenium, I'll start off with that. But basically the idea is you can generate virtually any scripting language you like, and even if it's something which is not a scripting language, if it's got an API layer, we could probably just call out to the API layer to create the tests. Okay, so that's the sort of core concepts. So I'm going to jump into the tool. Now, this is Agile Requirements Designer. Some of you may see it. It is available for a free download, so feel free to have a play. We are actually working on a series of model-based testing videos. Hopefully they'll be coming out in the next couple of months. So stay in touch with us. And once those videos come out, it's basically one of the problems with modeling is you don't know which type of model to create. Is it a data-driven test? Is it a negative test? How does it work asynchronously? What do I do with sub-processes, etc.? So we're trying to kind of give you a set of videos to give you some structure around that. Now, if you look at this model, this is sort of a logical model of a download. Okay. Now, where did it come from? What we actually did is I don't have time to show you, but we basically can import text. Each text block then becomes, in effect, a block, and then you start, is it a decision? If it is decision, what's the result? What's the order in which they come in? Now, let's just come in. We've got some test cases. I'm just going to delete them. We've already got some test cases. Now, if we come in here and do a thing called all possible paths, what you'll see is that there's actually 71 possible combinations. Now, that's actually quite small. What you'll find is the numbers go up into the millions, dependent on very complex change processes. Now, what you need to think about is some of our optimization techniques. So you might say, well, show me the minimum amount of test cases I can get away with to touch each function. And we're going to go off and actually create you 5 of them, and that's going to give me 5. And I might come in and say, well, show me something like, show me each decision, and each decision is called an edge. It's a graphical term. So that's an edge, and that means that we have created 7 test cases out of the 71, and those are going to cover each decision gate. And in some cases, you have multiple ways in and multiple ways out, and we would then go off and try, in this case, create you 8. So that's all very good, and that's really a lot, and there's all sorts of other ones as well, probabilistic based on user activity, and all pairs, which is a pretty traditional method. Now, say I come in here and go, let's do something like all nodes, and I'm just going to store those. So I've now created something called all nodes, and let's just create them. So I now have created 1, 2, 3, 4, 5. 5 test cases. Now, the question I've got to ask myself now is, how good a job am I doing? And if you click on the little $sign, what you will see in here is we're actually going to tell you what you've missed. Now, obviously, I picked a pretty rough and ready methodology, which was nodes there. Now, if I click on more, what that's going to do, it's going to show me which decisions I'm not testing. So when it's 0, what we do is we use a great thing called adding up. We basically count through the test cases to see which decision gates you've tested. Okay, and some of them we tested a lot, and typically the ones at the top tend to be tested quite a lot. If you click on this one, you'll see we haven't actually tested that decision. So by being able to, and this is actually quite useful when you import your existing test cases to find out what's missing. So you could, for example, supplement your existing test cases with some additional ones to just fill in the gaps. Okay, so that's a very, very swift introduction to the idea of kind of some of the optimization and coverage techniques, measuring it and generating them. Now let me just make sure I've got the right configuration set here. Yes, I have. Now I've got this one set up with a cucumber. What we've done here is, if you think about going down this way or that way, we've associated with each. What you'll find in Visio, you don't really get much inside a block. What we do is we've added a whole bunch of extra attributes, test data, you can add in images, you can do all sorts of things in there. And if you go to automation, basically what we're doing is we've added in a when clause here, like so. Now what does that mean? It means that we have a few test cases, and what I'm actually going to do now is I'm going to generate out of those test cases, which previously could have been manual test cases. I just need to connect to my data engine because I'm going to need to look up some data. And what you'll see is that we've created 5 test cases, and we've gone through and we have now generated the given when scenarios, and then what we've also done is we've come out with the expected result. So you'll see as we're going through, we've actually gathered up the expected attributes at the end. So that's what the signal signature should be. You'll see in here that we've also interleaved some data in here. Now, with luck, I'll show you some of the data stuff at the end. But you can see it's pretty easy to go from drawing a picture to actually generating scripts. You just got to kind of associate each decision gate with one of the automation activities, and I'll get into that in a second a little bit more. Anyway, so that's song streaming. Now the next one I'm going to show you is a thing called, this is a little web store. Now what we've done with the web store, let's just go off, and I think this one's in Chrome. So we've got a little web store like so, and you can select a product, and you can order a product, and you can fill in countries, etc., etc., etc. So now what we've done is we have gone through and we have built a model of the validation, the different selection criteria associated with this particular screen. Okay. Now, in this case, what we've done is we've created an automation configuration. Now, for the most part, for the majority of the main languages like UFT, Eggplant, RunnerX, Selenium, Cucumber, you know, some of the Microsoft products, etc., we've actually created these configurations. And what you'll find is that we've actually broken the language down into these object types and action types. What can you do with an element? I could check it, I could click it, I could send keys, etc. So we've kind of broken the language down. And then what we do is we come in here and I might say something like select product, and I look at my automation, and you'll see here that I've chosen an element click drop down by containing CSS, which is the action. Let's have a look at the edit, and that's brought in the script, but you'll see it's also, we can parameterize it up. Now the parameterization could come in by actually, you know, by a variable, or you could type it in hard-coded, or you could potentially look up the data from maybe using our test data engine from a back-end database or something like that. Okay, and you know, we've gone through and we've kind of, you know, Selenium is probably the one with the hardest work, and I'll explain why in a minute. Now, if you go through and say, well, let's go and look at, in this case, I've chosen a set of optimization called all pairs, and that's pairing up each decision gate to make sure that each decision gate is paired up. I'm just going to click on automation and click on export, and we'll let that run for a second. And what this is going to do is it's going to go off and generate us a stack of Selenium scripts. Okay, so you'll see here we've got a stack of Selenium scripts. Now you can also put assertions in if you want to, and you've got sort of it's a little, when it comes to generating automation scripts, you've almost got to think, if you're trying to create a negative automation script, you've got to tell the script it is a negative script, and it should therefore be, the assertion is that it should be expecting an error message. If it doesn't get that error message, then it has failed. So you've got to be a little careful, and when you're actually designing your kind of your scripts to, and what I tend to do is to sort of set a variable at the top of the script to say this is a valid script, this is an invalid script, and then at the end you kind of know whether, if it continues on and it was an invalid script, then that's a failure. Okay, so you kind of do this sort of double negative as I talked about before. So that's my kind of all pairs. Now what I'm going to do now, I've just got my Selenium, I'm just going to run protractor, and what that's going to do is to pick up those scripts that it's running, and what you'll see now is that's now going to go off, and it just takes a little while to bring up the first image, and then off he goes. Now you can see it's coming up with lots and lots of assertions in here, and that's just hammering through. Now in this case what we're going to end up with is we're going to end up with some JUnit run results. Okay, now I'll just stop that for the moment because that just runs through. There's 31 of them, which is a bit boring for you guys to watch. So that's going to give us 31 results. Now what I'm going to do is I'm actually going to show you what we do with those results. I'm just going to open up a flow. Let me just go find it. Now this is I'm going to show you how we can use those run results now to diagnose where the problem could lie. Okay. Now this is the flow. And if we go and look at our test cases, now in this case, for the use cases, we actually started off with just 8. We just did a very rough and ready set of test cases. Now what happened was that let's go and look at our use cases. You'll actually see here that that one failed. So that particular combination, this journey through the flow, failed. So something in here, or some combination of I guess maybe attributes, or maybe the particular types of activities that you're performing has caused a problem. The other ones were fine. Okay, so now what I'm going to do is I'm just going to do a thing called calculate regression. Now this is using a thing called regression modeling, and what we're doing is we're trying to find a correlation based on the information that we have, because we've only got 8 of them here, to say what is the strongest correlation as a potential thing that could cause us, could have caused the error. Now, you know, this is some pretty interesting stuff, this, I mean, if you're into regression modeling. But actually from the point of view of, you know, what do most people now when they have an error, they've got to go and give it to the programmer, they've got to try and recreate it, you know, all the sort of boring stuff that people have to deal with. So I'm just going to pop those over there. And what I'm going to do now is say, go and generate me some new test cases. I'm just going to call it diagnose. And that is now going to generate me another set of test cases. And I think there are 48 of them. And what we would do then with those other 48 cases, we would now generate a new set of Selenium scripts. Okay, so those Selenium scripts will come out. We've gone from 8 to 48. Now what I could do is I'm just going to go off and show you those. It's actually this lot here. What I'm going to do now with these is I'm again going to calculate my regression. So these are the results of the test cases that we created based on those. I think there was, what, about 8 or 9 of them, potential problems causing the problem. So we focused in on those. And if you click on, calculate regression now, you'll actually see that we've diagnosed and we've dropped into these 3, 1, 2, 3. Now we could create a bunch more test cases around here, but actually you can almost see that the problem is every time you click Scotland, there's a crash. And you know, a little bit like Brexit and Scotland wanting to stay in the EU, you know, that's actually going to be a problem for the British government, and this is a problem for our script here. So, so that's using this this diagnosis engine and then generating the appropriate test cases to go and try and diagnose that problem. Okay, so that's how you go about the idea of actually sort of associating the model with the scripts. Now, let's just close that down for a second. A few of these, too many opened. Just start again. So what I'm going to do now is I'm going to move you on now into different approaches to this. Previously, we sort of created a model and we associated blocks with scripts. Now, in this one, we're using a fantastic little product called Test Plant. Sorry, it's called Eggplant from a company called Test Plant. And in this case, what we're doing here is we have again created a configuration option. And this basically looks something like this. And the way that Eggplant works is it works on image based. It's an image or character recognition technology, and they've got a very simple language associated with it, like so. Okay, and you can sort of type that language in, but you know, click button. You might want to say click button, and then you might want to have an assertion saying something like assert button has been clicked. You know, which is a validation routine. So you might actually end up with 2 to 3 to 4 lines of script associated with particular types of. So here. Actually, we've all gone pretty simple with these here. Now, what we can do here as well is one of the things that you might want to think about is, well, how do I actually build a script? Now, you could build a model like this, but what we've done is we've allowed you to come in and say, well, in this case, I could use the thing. I could just type the word CL. So in other words, it's a context-sensitive typing. So I could say, let's do click by image, and I'm going to call the image NOP login. Okay, and then I could say the next one might be click by image, and this could be choose. So this might be existing user. Okay. and let's do something like enter text, and I'm going to say no. Now what we're actually doing here is we're actually creating, if we look in the automation at the back end, you'll see that we're actually coming in and we are in effect creating the appropriate automation scripts as we type. So you can almost, you know, especially for exploratory testing, you could sit there, you could just in effect type, and it will build the automation scripts for you. And then once that would then create you one block, and then you might move through the next block, to the next block, to the next block. And then really it's only then some of them you might say, well, select male gender, that actually should be a decision. So we're going to change that to a decision. You know, if it's male gender, you might want to go off and go into a different, maybe a location, and depending on whether you true or false, you would set male or female like so. Okay, so what we're doing there is we're coming through and we're using we've sort of taken the idea of the text, but we've allowed it to be a very simplistic language which rolls up into maybe complex text, so you can actually just type as you're pushing stuff through. Okay, so that's using something like Eggplant, which is sort of character recognition. There's another one out there called Zap Test as well, which is a pretty cool product also. So that's that one. Now the next one I'm going to show you is from a company called RunnerX. I don't know whether you guys have heard of them. They're show up at most shows. Again, they're a very strong, so let's just have a look at the flows here, probably one of the best automation tools around. We actually use it ourselves to test Agile Designer, so we've actually modeled most of Agile Designer. Now here you've got a thing called a login panel, and if we just open the Subflow in a new tab. Now what you'll find when it comes to automation is that very often there are very common objects and common activities that you care about. So instead of you having to, for a login panel, or it might even just be as simple as entering text onto a screen, or you know, having text longer or greater than a certain value, you can create these common objects and then call them in to your master. Now that's obviously very powerful, and then let's just make sure I've got the right configuration here, which is RunnerX. Now the RunnerX one here, you'll see, again, we've sort of, the headers and footers tend to go at the beginning, and then we're sort of into checkboxes, set unchecked, validate exists, and you'll see here that we're creating the various different activities, like so, and then those can be dropped onto the palette. Now, so that's fine, and if we go and look at the login wrapper, then we can go in and we can say, well, let's look at all possible, what have we got, and we've got 7 of them, and those 7 actions can then go off, and let's just, sorry, 7 test cases, and what we can do now, those 7 test cases, is just click on our, by the way, this is being recorded, so I'm going at the speed of light given the shortness of the hour, so you do have time to, when you get the recording, to go back through this. So if you are an Eggplant user or a Selenium user or a RunnerX user, feel free to kind of have a look at this in a little more, a slightly slower pace than I tend to go. So if you come in here and click on export, and what we're going to do here is we're going to just pop off and have a look at just pick that. I just need to go get some test data. And here you'll see that in this case what we're doing is we're actually then generating some RunnerX scripts, and what I'll do is just go off into RunnerX, and here those are those same scripts, and let me just run this. Let's just go and have a look at one of those scripts. So that's the script that we just created, and let's just go over here and just click run. So this is now going to, again, we've just created, just building the commerce script a moment, give it 1 second. So, so again, what's happening here now is that we've done some modeling, we know the objects that are on the screen. Now there are various sort of object spies, and I'm going to show you how to use those in a minute. You know, Eggplant have one, RunnerX have one, there are various kind of tools out there. And quite often what you might want to do, it depends at what stage you want to build your automation. You could think, the reality is that this is the RunnerX script running now, so we'll just let that run while I'm chatting. You could actually, if you know the names of the objects that you're going to be putting onto a screen or to an API or something like that, then the reality is you should actually be able to generate your automation scripts right at the beginning of a sprint. Once you have those automation scripts available, then actually you think about it, you've got them available then for not just the testers at the end or the regression testers, you've actually got them available for the developers. And in my team, when we generate automation scripts, you'll often find that the developers are actually running them way early in the cycle just to make sure that the screen is behaving as was designed. Okay. Now the other way to think about it is that you've actually got an existing screen which has sort of disappeared almost into kind of a waterfall type mode. And what you now need to do is to sort of take the objects from the screen. So that's gone through and that's all worked perfectly. In that a bunch of them were negative tests and magically they all worked. Okay, so that's just using RunnerX. Now, if you come in and say, well, what we've also done then is created these connectors. This list is growing all the time, so I'll just show you what we have at the moment. So what you could do, if you looked, previously we had a configuration. We were looking at this configuration file which contains the code snippets. But what I could do is I could actually just drop the action associated with checkbox directly onto the palette. So I could call this checked mail. Or sorry, the next set's checked do not email. Okay, and that's now created a block. So that block is now available, and if we look in there, we'll see we've added an automation activity. The object name is called do not email, and in effect, when we create the script, that object name would come through like so. So you can sort of find the actions, the automation actions, drag them on, give the names. Obviously, you know, if it's a very simple, straightforward text, sort of test case where you're kind of running from top to bottom, that's a bit boring. But actually, it's always when it gets more interesting is when you're drilling down into these decision gates and maybe loops back and all those types of things. And that's obviously where the power of the tool comes in that it can generate all the different combinations of them, like so. So that's one way of doing it. The other way to think about it is to say, well, let's go off and pick maybe an existing project. So what I could do now, actually, let me just switch to, I'm going to open the login panel, open my Subflow. Now, what I'm going to do now is I'm going to go and open, let's go find that project. So this is NLP Commerce, RunnerX project, let's go find that. So that is the project sitting over here that we were using before. And if we go into this and open it, now what you'll see, these are the actual in effect the elements that exist on the screen. Now of course what often happens is that they do an upgrade, they might rename some actions on the screen itself, you might change some names, you might change some XPaths, all those different things can happen. Now what's happened here is that we have detected all of the automation activities that already exist inside this flow, and we've detected there's a difference. So what we'll do now is if we click on OK, it is going to automatically update the references to the objects from the screen. Now in this case, this lot has come in from the RunnerX Spy tool, okay, and all we have to do is turn it on, it auto scrapes it for you, and away you go. So we just click on OK, and that's going to allow you to in effect do that. I won't do that for the moment. So that's a sort of a synchronization capability. As you hover over, you're going to see the particular GUIDs, the types of tags, etc., etc. But what you can also do from this one, and this again is quite cool, is you could just literally drop on register. And what will happen there, it's given it the object name on top of it, and you click on OK, and that's going to give you an input tag like so. And that, in effect, is a register button associated with that screen. So you could just drag from your scrape, put some logic on it, parameterize up maybe some of the data that's going to be passed into it, and out of it you're going to end up with a set of test cases and data like so. Okay, so that's sort of 2 or 3 different methods. You could use something like RunnerX, you could use the automation configure actions for Selenium or something like that, or with Eggplant you could also do something, they have an image library, they capture images, and all in effect you would be doing is dropping the image on the palette, say what you want to do with the image, I want to click on it, I want to identify it, I want to enter some values, into some text into that particular image place. So there's a few different methods, and this particular set of connectors is growing all the time. Okay. So that's hopefully a pretty cool method for you to play with. Now I'm going to show you a little thing about change. I've sort of deviated from my agenda slightly. I got sort of a bit excited, but there we go. So let's go off and look at this one now, which would be something like claim entry adjustment and status. Now, one of the biggest problems is that people with modeling, you know, is first of all, okay, let's start up front. First of all, you've got to build a model of what you want to create. Now, you could import your existing test cases, and we've got one customer who's currently importing all their HPQC and ALM test cases, and they're optimizing them up, and then they're actually generating a new set of scripts out of them, like so, and they're building a model, reverse engineering a model out of the actual existing test cases. You could import text, you could import, you know, XPDL or BPMN tools, and in some cases we can import some Visio diagrams if they've been constructed correctly. Now, but you don't need to model entire systems. Here you've got something called claim JIRA rules changed. All I care about are those are the three things that could happen. I do not have to go in and model everything. In fact, I haven't even got it. So basically, I don't even need to go in and model what the J rules are. That particular model sitting there is all about. All I care about is these ones. So you build enough of a model that you can generate the automation script or generate the test cases. Now, if we come in here, you'll see that we've got 8 test cases already. And let's have a look to see how good a job we're doing. And we're coming in, and we're up to about 100%. In our edge coverage, we're actually at 91%. So we're missing one or two things. What are we missing? We're actually missing that one, which is, sorry, that one and that one. We don't have a test case for that, and we don't have a test case for that one and that one. So I could go back and do a little more work on generating some test cases, but I am where I am. I've basically got 9 test cases. So let's just go now, and I'm going to make a change. So I'm going to come in here, and I'm going to add in a typical one, which is we're going to introduce something like a manual override, like so. It's a user interaction, and it's either true or false. So we finish. We've now got a new decision gate that we need to put into our model, and this is really where, you know, the tool really comes into its own. We had, I think, one customer who every single change to the requirement, they had to spend, the whole team would spend the whole day going through all of their test cases to see what had changed, because it was all in spreadsheets. It was a nightmare. So now we've got that down to a couple of minutes, because obviously we just change the model and the new test cases get updated. So manual override goes to there, otherwise it's going to drop down into that world there. So that's going to give us something like so. Now, if you now go and look at your test cases, what you'll find is that 3 of them are now broken. So the first things first, I didn't have to identify the 3, the tool did, so that's obviously very useful. And I can click repair, so that's the second thing. That has now repaired my test cases, and I could now regenerate my automation scripts and continue on, and, you know, I'm good to go. Now, the reality is that if we go and look at our, you'll see how our edge coverage has now dropped, because obviously, as you would expect, we do not have a test case for this manual override. We've just gone straight down the false. So we're kind of missing a few decision gates. Now, what you could do is you could come in and say, well, I've already got some test cases, so I'm going to add to my existing. Let's go find something like all edges, and let's go find, and we've basically found 2 extra test cases that we could add in, and those would then take us back up to our, so we'd end up with 10, and we'd go up to 100%. There is another way to think about it and say, well, I'm just going to throw them away. And to be honest, it's a much better way to go with this tool, is that because we are generating the scripts and measuring the coverage as we go, as you know, it's obviously based on the fact that you model things correctly. The idea then would just be in effect to generate something like an all-in out edges and let it rip. Let's do, sorry, all edges again, and we're back to 8. So basically, instead of going up to 10, we've actually kept the number of test cases down. So quite often, when you actually put new features in the tool, in your application, we don't particularly need to adjust the total number of test cases. We could actually just go in and reduce them down, because we're in effect merging and folding test cases into the minimum number we can get away with. And what you find is typically over time the number of test cases grows to insane numbers, but once you move to this model the number of test cases grows very, very slowly, because you just, and in fact what you're doing is you're really creating longer chain test cases. There tends to be quite short burst test cases just testing one feature, whereas actually if you could actually merge together a lot of test cases into one. The thing you have to be careful about though is that once you go to longer chains, you can't just say if one test case out of 100 failed, that may well be testing a lot of things. So you can't just say, well, 1 out of 100 ain't bad, we're going to let it go. You might have to fix that and then rerun them. And the reality is you should only really push on when all of the test cases pass, and I think that's sort of an important thing to remember once you go to a fully sort of optimized set of test cases. Previously you might just say, oh well, it's just one edge case which we don't really care about too much, but you have to be a bit more structured about that. Okay, so that's this idea of change, and pretty much any of those models that we created before, you could just go off and make a change to them. Now, what I'm going to show you now is about data. Now, one of the key things about automation is getting the right data in the right place. So let me just look for something like, let's just open stock testing. So, and let's just open the Subflows. So let's open those. So what we have is, what I'm trying to do is I'm trying to create a set of data for my automation scripts to run to check a stocking algorithm. Now the stocking algorithm is going to basically stock the warehouse or not stock the warehouse to certain degrees, to a certain or lesser degree. Okay, so what I've done is I've actually built a model of the different types of data that I'm going to need. All right, and then in parallel to this, what I'm working on then is to create the automation script that's then going to go off and actually sort of run the tests. Now each combination of data, and in here we are actually dealing with different types of data that's going into, in this case, specific tables, warehousing, inventories, and these are the transactions and events, which would be the credit card transactions purchasing specific products. So we'd obviously need to create a whole bunch of events or transactions, and then also we could do the same thing with inventories. We could stock to a lesser or greater degree. Now, so if you go through like that, and then if you look at this one is, if we just go inside that block and look at automation, what we actually have here is that we've come in and we've created a virtual response. Now, one of the very important things to think about when you're dealing with automation is that it's very difficult with automation to actually go off and stabilize the systems that you're connecting to. Now, using a product like CASV, you can create the appropriate endpoints to stabilize the automation script. The automation script is testing all the stuff to do with your system, and you don't particularly care about the other systems. You're not testing the other systems for this set of automation scripts. Now, to do that, we need to generate these particular, in this case it's some JSON request and response, but you'll see in here we've parameterized it up like so, and that means that based on the particular routes through here, I would also generate the appropriate request responses. So if I come in here and I won't do them all, let's just delete a few of these. Let's just go through and delete one or two of them. We've got quite a lot. And let's just generate them. Now what we're going to do is we're actually going to generate you the data. Now when I say generate, the data, so this is our request, let's go down here, that's our request, and that's our response. And then what we've got is a little, there's a product called CATDM, and that allows you to find or make the appropriate data. Now, when most people think about test data, the first thing they do is go and look for it. So what we've done is we've created this ability in the product to go and say, go and find me, so I could come in here and I could actually go and find a set of data. and I would go and look for, based on some criteria, for some data, and that means that we would then hunt in the back-end databases for the data appropriate for this particular automation script. If we can't find it, we could then generate it. We could actually create that data for you. So what we're doing is we're bringing the idea of modeling in, linking it with the test data management tool and also the virtualization tool to actually create the appropriate data and endpoints that you need to support your automation. Okay, so that's one final thing. I'm going to do one more thing and then I'm going to stop because I have been ranting endlessly here. Hopefully on the right track. So I'm just going to go in and show you one other thing which I think is really important, and that is to what level do you test? Now, if you think about a set of, most testing now is kind of chaining together of activities, that's especially as we move towards microservices and kind of APIs and SOAP calls and REST calls and all the rest of it. Now, if you look here, what you'll see is these are actual subflows. So I'm just going to open them and I'll come back to this screen. Now each subflow is doing its own thing, and it may well not have been designed by me. I don't particularly care who designed these. So this is API 4, this is API 5, this is API 6, API 3 calls API 4, and then API 2 calls API 3, which calls API 4. Now if you look at this particular optimization technique here, now what we're saying is this is the calling structure, but what I'm really interested in testing is maybe 6. So I can set these other ones to, in effect, a minimal set of testing. So for this one I'm going to set that to all possible. I think it's probably going to stay at 5, and then the other ones I'm just going to set to minimal. Now what that means is that in effect we're doing an exhaustive test on this one, and the rest of them are just there as almost traveling just to get you through to it. So it's almost so we're almost using the other ones to get through the process, but here we're actually going through and exhaustively testing that one. If you go into maybe that one and then you go down to the next one, then you might be going, well, let's go and do all possible on this, and what you're doing now, I need to set these sub ones as all possible as well. This would then roll up into, let me just do stored paths, that's right. So stored paths here actually is an exhaustive test of the subflows as well. So it allows you to design your test cases in a sort of more structured way. You know, if you did 5 times 20 times 10 times 50 times 60 times 32, you get to some very large numbers. Whereas if you think mostly about chain testing, what you're interested in is getting to the point that you want to chain test and then exhaustively testing that particular component to death. Now that quite often can only be done if you virtualize up some of the so if API 2 needs to go off and call some other activity, or maybe some database stuff or something like that, or has a REST call, you might have to virtualize that to make sure you cover those 10 bits of combinations of data, like so. Okay, so let's finish with demos, and let's just go back to this, and I'll just quickly summarize. So we've got this idea of automation test blocks, we've got this idea of automation objects, which you can either drag onto the palette. If you've got something like a spy tool to be able to do that, you could drag the text blocks on and then allocate them to activities, or you could just start at the beginning with a model, with defining a model, associate the blocks with particular activities and object names, drop them on. Key thing here is test data. Most automation scripts are pretty heavily dependent on data. A lot of people write a lot of tear up, tear down scripts to create the data at the beginning, maybe creating a specific customer, etc. So we can obviously facilitate that. Out of those keywords, we can then create the actual scripts and the test data as well. And then you've got your test automation frameworks, which sit there. And I think the key point in the New World Order is that what we can do is we know that this decision gate specifically, and what we do is we store a GUID with that decision gate. So what we recommend is that there is one of our tags which allows you to put a GUID into your automation script. Now, what does that mean? It means that when we import the run results in and we detect that we've gone from this GUID but we haven't made it to that GUID, then actually the failure is at that decision by that. So there are some sort of slightly more advanced things you can do to think. I quickly showed you the diagnosis engine, but the reality is the more information you pass into your automation scripts, and again, that could just be a log message or just something going into maybe a CSV. It doesn't really matter. It's very simple to add that into the framework. Then that means when we do our diagnosis, we can actually track back through the model as to exactly which gate was being passed into it. So that's a very important thing as well. Okay, so with that, we now have time to go to the Q&A. No one has interrupted me, which means hopefully
well, yeah, that was such an incredibly comprehensive demo. I didn't want to interrupt you because there's so much great information in there. So
yeah, I thank God you're recording this, because I think there's a lot of people are going to have to go through this probably a bit more slowly. I mean, I've thrown a lot of information out there, I think, and I think there are some videos around all this stuff if you kind of want to just go through a bit more slowly. But we have, I mean, in one site we've reduced the cost of testing by 70%.
It's amazing.
And I mean, they did that. They were originally going to do it over a year, but they did in 6 months.
Wow.
Now they didn't do that by magic. What they'd done is they'd already created enough. The framework was a solid automation framework. Now we don't build those frameworks. We just support them by generating the scripts and the assets, to feed the beast, really.
Mm-hmm.
And we will help you kind of improve that automation framework. But there are so many automation frameworks out there. We thought, well, we're not going to give you one. We're going to just support yours. Now, Rabobank, who did reduce the cost of testing, they had spent a significant amount of money creating a very, very strong automation framework, which included virtualization. They hadn't done too much on test data, actually, but they created a keyword framework. They had a cucumber framework, but they then got stuck in that every single time they made a change to a screen, they were scrambling like crazy to sort of keep all these scripts up to date. In the end, it just became completely overwhelmed them. And that's kind of where we came along. Anyway, so what have we got on the question front?
Well, yeah, I did want to remind people that, yes, this is being recorded, so if you feel like you need to go back and watch this again, you will have the opportunity. And I believe the link actually to the recorded webinar will be sent to you in a follow-up email, but if not, if you don't receive that, you can always check the devops.com website tomorrow. Give us about 24 hours or so. But we do have a couple questions, and it's not too late if you do have a question for Hugh regarding the demo or anything else related to that. Please feel free to go ahead and put your question in, but we do have a couple things here we can go ahead and take a look at. Let's see here. Michael is asking, in order for this to work correctly and efficiently, it all starts with the requirements following a specific protocol. The flows and test cases will all be built from there. Is that correct?
That's a very interesting question. It's where do you start? Now, in my team, which is an agile team, I don't care. I genuinely don't care. It could be we have one tester in a team of 20, and it could be the tester who has to create the automation scripts, or quite often it could be me building a model which then the automation scripts come out of. So in terms of the person, in Agile everyone kind of does things in parallel, and there's a lot of wearing of many hats. So I think at some stage or other you have to create automation scripts. I mean, that's why we're on this webinar at the moment. Now, what we found actually is that quite often it starts in the automation team. The automation team have to build the automation scripts, so they'll build a model which generates the automation scripts, and they get very good at that. Now, what they also find then is that the BAs and sometimes the testers, if they still have manual testers, would be very interested in those models. So they would then go and, with luck, start maintaining those models. Now, in a sort of perfect world, it's almost up to the BA and the tester to build the model at the beginning of a sprint. So what is this feature supposed to do? And they would sit there, and if you look at most agile rooms, there's a flow chart on the wall. People have drawn it out, and you use it as a bit of a collaboration tool, and you build that model. There are various shortcuts to doing that, and I think I showed you this idea of being able to just almost, if you have a screen already, just run spy on it. It tells you the objects. You drag them onto the palette, and you've got all the objects. Then you put some logic in them. So you say, well, I want to put in a set of negative test cases for passwords, for example. And you then attach the negative blocks to the inputs to the password column. So there are, methodologies and structures to kind of pay off what you would call almost technical debt, and or accelerators to do that. But the real benefit of this is in sprint 2 or sprint 3, when you've actually created, when you're actually generating scripts, and then someone makes a change to the application, and then you very quickly can go, to the requirements, and then you can just go back and change the model and push the data out. So it's a very good question, and it's a question that everyone battles with. But my answer generally is, well, you've got to check the script anyway. So if we can make you generate that script in a third of the time, use it, and the models will grow.
All right, great. Well, Michael has a follow-up question, which is, are the flows automatically created from the requirements, or do they need to be manually generated?
Yeah, I mean, so if we go back to, if I'll just quickly open up, go back to demo land, let's just go and look at some text. So if we look at this text, so that is a typical piece of text that people create, and what we've got is a rich text importer, and you can copy that in. Let me just Control V, assuming that one in. All right, there we go. So that would come in, and that then creates that, and you might want to say, well, some of those are decisions. Click on OK, and what we'll do is we'll parse that up for you, and we will create you a set of. So here we've got. Oops. Oh, here we go. So those are basically a set of decision gates that I've now got to play around with and actually kind of think about the logic with them. So, I mean, to be honest, it doesn't take too long. I would say you should really, I mean, for me to do this, probably take me an hour to be able to build the model out of that. So that's one way of doing it. The other way to do it is to actually, what you often find is that people have existing test cases, and that's very, very common. So what we do under those circumstances is we actually just import the test cases. So you end up with, so if you look at that, it's a really boring flow chart. So you've got boom, boom, and this could be hundreds of them like so. And then what we've got is a little thing which says, okay, let's go find some duplicates. And what we're going to do is we're going to look for those look like they are the same block or decision. So we're going to mark as duplicates. We're going to auto find the next, mark as duplicates. And we're literally going through and looking for duplicates in the diagram. So now what we've got in here is we've got a pretty powerful tool to look for different algorithms, because people obviously write in shorthand. There's all sorts of different methodologies. You might have block names. Typically, if you say login, enter text, enter password, click, and you say login, enter text, enter password, cancel, you're pretty sure that login and password come after each other because you've seen it twice. So that's really kind of what we're up to here. And then what you're doing is you're just pretty much whizzing through. Hopefully that's just mark as duplicates. And I think we're done. We might find any more. Mark as duplicates. One more, and then I'll deduplicate it. That should do it, and we're done. So what we do now is we've now got a tool which says, okay, go and first of all remove any duplicate paths, there aren't any, and let's just deduplicate the diagram. And what happens now is we will create you, I missed one, I missed the start 6. We will create you a model. Actually I didn't, that is correct. This is actually someone who had a very short test case. So what we've done is we've created a model out of existing test cases, and it's quite amusing actually, because what you tend to find is that it's a little bit like the swing, the picture of the swing. This is what the user wanted, this is what the programmer coded, and this is what the tester tested, with the swing going through the middle of the tree and all that stuff. So, I'm not going to minimize how long it takes, but the effort that you put in is very quickly returned, is probably the key point there.
Excellent, excellent. Okay, well, unfortunately, we are out of time. If you didn't have your if you didn't get your question answered, I'm sure Hugh will be more than happy to follow up in email. But for now, I would like to thank you for joining us. And if you had such a great time, come back next Wednesday at 1 p.m. Eastern, and we'll do it all over again. I also want to refer you folks to the DevOps.com website. We did do a podcast with Hugh a couple weeks ago, so just go to the site and do a search for Hugh Price, H-U-W Price, and the podcast should show up. But meanwhile, Hugh, thank you so much for such a great demonstration and webinar, and we'll speak to you again
there you go.
next
Just
week.
quickly, that's my email address. If you do have any follow-up questions, I apologize that I went through rather rapidly there. I kind of excited. Send me an email and I'll get back to you with specific answers. Thanks so much.
Excellent, excellent.
Bye-bye.
Well, thank you again for joining us, and have a great day.
Thank you. Bye-bye.